Welcome back to Max with RP. Today we are going to be discussing a worksheet on matrices and determinants. This will contain chapters pertaining to the topic on matrices and determinants, but not in any particular order, in a random order. So let us see how many problems we can solve. Look at the first problem. Determinant A is the value of the determinant of a matrix of order 3. So you have a matrix 3. You have to find the determinant value of minus 2a. So suppose you have any matrix of order 3. So 1, minus 2, 3, 4, 5, 6, 1, 0, 0. Suppose this is a. If I multiply by say minus 2, minus 2a would mean I multiply every element by minus 2. So this will be minus 2, 4, minus 6, minus 8, minus 10, minus 12, minus 2, 0, 0. If I take the determinant, then the determinant of minus 2a would be the determinant of minus 2, minus 4, minus 6, minus 8, minus 10, minus 12, minus 2, 0, 0. But in a determinant, if I have to take out a common term, suppose I take out minus 2 from the first row, then I can have to take out 1 minus 2 from the first row, 1 minus 2 from the second row, and another minus 2 from the third row. So if you have a matrix of order 3, which is A, then determinant of minus 2A will be minus 2 cube into determinant of A. Are you able to follow? Because in a matrix we multiply every element by a scalar. Alpha times A means every element of A will be multiplied by alpha. So minus 2 times A would mean every element gets multiplied by minus 2. However, when you look at the determinant value, you can take out minus 2 is common in the first row, you can take out on minus 2. Minus 2 is a common element of the second row, you can take out another minus 2. Minus 2 is a common element of the third row, you can take out another minus 2. So you can actually take minus 2 cube into determinant of A, which is minus 8 into determinant of A. So this is on the basic principle of matrices and determinants. Now let us look at the next problem. This is a multiple choice question. A is a square matrix of odd order such that Aij is equal to I cube minus j cube. Then what can you say about the matrix A? See, you are given that Aij is I cube minus j cube. So suppose I want to find Aii. I will get I cube minus I cube, which is 0. So the diagonal elements of a matrix are 0. Also, we know that in a skew symmetric matrix, the diagonal elements will be 0. Now, also in a skew symmetric matrix, what is the definition? A equal to minus A transpose. A matrix A is called skew symmetric if A equal to minus A transpose. In general, we know that determinant of A is the same as determinant of A transpose. So determinant of A will be 0. Because I bring this to this side, I'll get twice of determinant of A, which will be 0. So it is a skew symmetric matrix whose determinant value is 0. Please check, this is true only for odd order. Aij is I cube minus j cube. So if I find out the diagonal elements, they will all be 0. And since A is minus A transpose and determinant of A is minus determinant of A equal to 0, you can also remember this as a property that in a skew symmetric matrix, the diagonal elements are equal and its determinant value is 0 if the square matrix is of odd order. Next problem. A is a square matrix such that A square equal to A. You have to find out what is I plus A the whole square minus 3 times A. So you are given A square equal to A. You need to simplify to find I plus A the whole square minus 3A. This is I plus A times I plus A minus 3A. This is equal to I. Here we have to use the properties of the matrices and matrices. So I into I is I square. So any matrix you multiply with I, which is called as the identity matrix, you get back the same thing. So I square is I. So I into I, which is I square, which is I. AI, any matrix you multiply with I, it is like the role of the number 1 in the number system. So you multiply any matrix with identity matrix, you get back the same matrix. So AI is A. IA is also A. Plus A into A is A square minus 3A. This is I. Now what is A square? A square is A. So you get A plus A plus A, 3A minus 3A, which is I. So the correct answer is C subdivision, which is I. So we are making use of the fact that any matrix you multiply with identity, whether left or right, you get back the same matrix. AI is equal to IA equal to A. We are also using the fact that I square is I, and we are also substituting for A square as A, as it is given that we are dealing with a square matrix such that A square equal to A. So these are the properties of matrices which are very important and their application, and this is a problem which tests on your understanding of the properties of matrices. Next problem, alpha and beta are the roots of given. Alpha and beta are roots of x square plus x plus 1 equal to 0. Then what is it that you need to find? You need to find 1 beta alpha alpha into alpha beta 1 beta. So this is a problem on multiplication of matrices and also using the fact that alpha beta are the roots of x square plus x plus 1. So first let me multiply this. How will you multiply? The first element will be first row of the first one with the first column. So 1 into alpha plus 1 into beta, which is alpha plus beta. This element will be first row, first column, 1 into beta plus beta into beta. So beta plus beta square. This will be this row into the first column, alpha into alpha plus alpha into 1. Alpha square plus alpha. The last element will be alpha into beta plus alpha into beta, which is 2 alpha beta. Now, we have just multiplied. We are still to use the fact that alpha and beta are roots of this equation. So, what are the facts we have? This implies what? Alpha plus beta, the sum of the roots, is minus b by a, which is minus 1. Alpha beta, the product of the roots, is 1. We also know, since alpha satisfies a root of this equation, alpha square plus alpha plus 1 is 0. So alpha square plus alpha is minus 1. Beta is also a root of this equation, so it satisfies the equation. Beta square plus beta plus 1 equal to 0. Beta square plus beta equal to minus 1. Now will you make use of all this? So what will we get? So alpha plus beta minus 1, beta plus beta square. Beta plus beta square is minus 1. Alpha square plus alpha minus 1. 2 alpha beta. Alpha beta is 1. So 2 into alpha beta is 2. So what is the correct answer? Minus 1, minus 1, minus 1, 2. So this is the correct option. So in mathematics, sometimes you need to combine ideas or combine topics in order to solve a particular problem. Here we have not only used the concept of matrix multiplication, we have also used the concept of sum of the roots and product of the roots of a quadratic equation. Now you are given next problem. You are given a matrix and you are asked to find the determinant of adjoint of A. I hope you all know that determinant of adjoint of A is equal to determinant of A to the power n minus 1, where n is the order of the matrix. So adjoint of A is the concept that you use in A inverse. Recall, A inverse of a matrix is adjoint of A by determinant of A. Okay. Now determinant of adjoint of A is determinant of A to the power n minus 1. Now what is determinant of A? How will you find the determinant of this matrix? You can always open and find the determinant, but when you have an upper triangular matrix like this, see here there are zeros. Then the value of the determinant of A is the product of the diagonal elements 2 into 4 into 8. This is 2 into 2 square into 2 cube, which is 2 power 6. Now what is n? N is the order of the matrix, which is 3. So n minus 1 is 2. So determinant of adjoint of A will be determinant of A to the power n minus 1, 2 power 6 to the power n minus 1, which is 2. So this is 2 power 12. So the answer is 2 power 12. So always remember, determinant of adjoint of A is determinant of A to the power n minus 1. Look at the next problem. A into adjoint of A is the given matrix 3, 0, 0, 0, 3, 0, 0, 0, 3. You have to find the value of determinant of A plus adjoint of A. So A into adjoint of A. What is A into adjoint of A? Is determinant of A into I. Again, this is a fact that you ought to remember. A into adjoint of A into adjoint of A is equal to determinant of A into I. Please remember, it's a very important property of matrices and determinants. Now, what is A into adjoint of A? It is given as, what is this? I can write this as what? See, this is a matrix. So this is nothing but 3 times I. So 3 times determinant of I, which is 1, which is 3. So A into adjoint of A is 3. So what is determinant? That means what? Determinant of A is 3. See, this is 3 times I. Okay, A into adjoint of A is determinant of A into I. So it is 3 times I. Right? It's a matrix. So if I take out 3, I'll take out from every row. So I'll get 3 times I. Therefore, comparing these two, determinant of A is 3. But what are you asked to find? You are also asked to find determinant of adjoint of A. So what is determinant of adjoint of A? Is determinant of A to the power n minus 1, where n is the order of the matrix. N is the order is 3. So it is determinant of A to the power 2. What is determinant of A? 3. So 3 square, which is 9. Therefore, determinant of A plus determinant of adjoint of A is 3 plus 9, which is equal to 12. So the correct answer is 12. Are you able to follow? Now look at this problem. You are asked to find determinant of A times adjoint of A. I think it has to be determinant of adjoint of A. Let's find determinant of adjoint of A. You all know the determinant of adjoint of A is determinant of A to the power n minus 1. Okay. Now, determinant of adjoint of A is what? Let me put adjoint of A as some x. Then determinant of adjoint of x will be what? Determinant of x to the power n minus 1. What is determinant of x? It's adjoint of x is adjoint of A. Now what is adjoint of A? Determinant of A to the power n minus 1. So determinant of A to the power n minus 1 to the power n minus 1, which is equal to determinant of A to the power n minus 1 square. So please remember this as a formula. Determinant of adjoint of A will be determinant of A to the power n minus 1 square, where n is the order of the matrix A. I just shown how you get it. Okay, adjoint of A I have kept it as x. So determinant of adjoint of x will be determinant of x to the power n minus 1. Now determinant of x is nothing but determinant of A to the power n minus 1, and outside there is another n minus 1. So you get determinant of A to the power n minus 1 square. Now what is determinant of A? Determinant of A will be minus 2 into, this is what, minus 2 minus 3. So this is minus 2 into minus 5, which is 10. These two elements are 0. I am opening using the first row. Minus 2 into minus 2 minus 3, which is minus 2 into minus 5, which is 10. So determinant of A is 10. What is n? N is 3. So n minus 1 equal to 2. So determinant of A to the power n minus 1 square will be, what is determinant of A? 10 to the power 2 square. N minus 1 square. So 10 square into 10 square will be 10 to the power 4. What is 10 to the power 4? This is the answer. This is a very short video on very simple problems which can be asked as multiple choice questions in the board exam. I hope you found this useful. I will discuss more and more worksheets in the further videos. Until then, goodbye.